There we go. All right. So let's start off by doing a little bit of code reading. So Trey, I'll have you start us off. I'll have you read lines 1 through 4, and then let me know if you would like any examples or demos on anything.
Yeah, I didn't get to the code reading section. Sorry.
Yeah,
But I mean, yeah, if you would just give me like a starter.
of course. Yeah. So the way that I would read line 1 is the function convert minutes to seconds is being defined with one parameter, minutes of type number, and a return type of type number. So just noting, okay, what function is being defined? Oh, the convert minutes to seconds function is being defined. How many actual parameters are inside? What are those parameters called in their types? And then what is the overall return type of the function?
Okay. So since you did line 1, line 2, we're going to have minutes, or the result of minutes times 60 is being assigned to the variable seconds, which is a type of number. And on line 3, it's going to return seconds. And on 4, we have the closing curly braces.
Perfect. Yeah, thank you. Rukaya, could you do 6 and 7?
Okay. So on line 6, we have, so we're calling the function convert minutes to seconds with the argument 5, and we're assigning it to the variable convert minutes to seconds result of type number. Is that correct?
Yep.
Okay. And on line 7, the log method of the console object is being called with 2 arguments, a string and the variable convert minutes to seconds result.
Awesome. Thank you. Caroline, are you around?
Yes, I'm here. Sorry, but I'm driving. I just wanted to listen in.
Oh, yeah, no worries. Yeah. Thanks for letting me know. Okay, then I'll do some code reading here then. On line 9, the function greet is being defined with one parameter, name of type string, and a return type of string. On line 10, the string is being concatenated with the variable name, and that is being assigned to the variable greeting of type string. On line 11, greeting is being returned, and then on line 12 is a closing curly brace. Trey, could you do lines 14 and 15, please?
So on line 14, we have the function greet is being assigned to the variable greet result, which is type of string. And on line 15, we have the log method of the console object is being called by 2 arguments. First is a string and the variable greet result.
Awesome. I might have zoned out, so I apologize if you did do it. But whenever we call out that we're calling a function, we just want to note how many arguments and what those arguments are. Awesome. So, Rukaya, could you do 17 through 20 and let me know if you would like an example?
I'm going to try it. A
Okay.
function named getArea is being defined with 2 arguments, width of type number and height of type number. And, oh no, it's an arrow function. An arrow function is being defined. An arrow function getArea is being defined with 2 variables, width of height number and height of type number, and the of return value of type number. Okay, that was on line 17, sorry. On line 18, the result of the expression width times height is being assigned to the variable area of type number. On line 19, we have return area. How would you say that?
Yeah, area is being returned.
Okay, area is being returned. And on line 20, we have the closing curly braces.
Awesome. Thank you.
Thank you.
On line 22, getArea is being called with 2 arguments, 17 and 42. And that is being assigned to the variable getArea result of type number. On line 23, the log method of the console object is being called with 2 arguments, a string and the variable getArea result. Trey, could you do 25 through 28?
So the person interface is being created. I'm sorry, on line 25, we're creating the interface person with open curly braces. On line 26, we have the first name property with a type of string. On line 27, we have the last name property with a type of string. And on line 28, we have the closing curly braces.
Awesome. Thank you. Noah, could you please read lines 30 through 33 and let me know if you would like any examples?
On line 30, on line 30, the arrow function is being defined and assigned to the with one argument object person with the type string.
The type person. So this is the type of our parameter.
And the type person. And the type of the arrow function is string.
The return type.
The return type is a string assigned to a variable get first name. I need to read the line 30.
Yeah, 31 and 32, please.
32. The variable first name of type string is being assigned with the first name property of the person object.
Perfect. Only thing is we flip it. Whenever we see an equal sign, we start on the right and then we read left. If you're curious, the reasoning behind it, it's because it's the same way with the computer, where the computer can't create something unless it knows what to assign to it. And so computers actually start on the right and then they go to the left.
Okay. The return returning the newly created variable first name type string.
Awesome. Yeah, thank you. Let me move this right here. All right. So Rakaya, could you please do 35 through 39?
The function get first name is being called with one argument and object, and the result of that, and the return value is being assigned to the variable get first name result of type string. That was on line 35, sorry. Do I do 36 and 37? Do I have to read that as well? Because I mean,
yeah, you read out what's in the object as well. Yeah.
I'm sorry?
Yeah, you'll want to read out what's inside the object.
Okay. On line 37, the first name property is being, how do you read that?
The first name property is being assigned a string.
Okay, the first name property is being assigned a string, and on line 37, last name property is being assigned a string. On line 38, we have the closing curly brace with the parentheses, closing parentheses. On line 39, the log method of the console object is being called with two arguments, a string and get first name result.
Awesome. Thank you. All right, so I think the next one, Trey, was the one that,
Could you pin the like the solution for the code, sorry, for the function, because
I'll send it out after.
Yeah, please.
Yeah, I can send it out after. All right, so this next one, so I'll walk through this one, Trey. Let me know if you have any follow-up questions or anything. So with arrow functions have a little bit of an interesting syntax. So in our Q&A, we'll kind of talk about arrow functions versus normal functions, why I would want to use an arrow function versus a normal. But this function specifically is asking me to write it as an arrow function. So right here, I know what I want to call my function. I want to call my function get last element. So I already know in my head what I want my function to be called. I know right here, it'll be receiving one parameter or one argument, which will be an array. Now it's going to be any TypeScript array. I don't know necessarily what's going to be inside of it. You can see in my example, it's an array of strings, but it can also be an array of Booleans. So it can be various different things. It could be a string, it could be a Boolean. So I can't necessarily just say that it's going to always be a string array or always going to be kind of a Boolean array. It could be one of the others. What this function is asking me to do is it's asking me to return the value that is stored in the last index of the array parameter. So I'm going to be receiving an array as an argument, and I need to return whatever the value is that existed at the last index. So in my head, the immediate thing that I'm thinking about is, well, the first thing I need to do is I need to figure out what the last index actually is. So then if I didn't know that, what I would do is I would go back to my arrays exercise and I would think about how we found it out in the TypeScript arrays exercise. Immediately, I know I need to subtract 1 from the length. That's how I can find the last index. So now I'll actually start going through and then I'll write it. So I'll put these side by side so we can maybe see them both at the same time. Let me move this down here so I actually write it out. So I'm going to create an arrow function. So it's just like I'm going to be kind of creating a variable. So const get last element equal sign, because I'm assigning an arrow function to the variable. Now arrow functions, and I'll talk about this a little bit more in the Q&A. We'll go over the different types of arrow function syntax, but we'll have our parentheses. Inside of our parentheses is going to be whatever the parameter is for that function, which in our case is array, which is noted right here in our instructions. Then in order to actually create an arrow function, I need to do my arrow, which is an equal sign, and then a greater than symbol, which creates that little arrow. And then for our sake, I'll do a function code block. I'll talk about a little bit about the differences between if we do that versus not. I'm missing a few types here. So my array type, well, if I look right here, I can see that my array could be a couple different things. My array could be an array of strings, or my array could be an array of booleans. It might be other things. So I don't really know what's going to be. So what I'm going to type this as is I'm going to type this as an unknown array, because I don't know what data type is going to be inside. Is it going to be strings? Is it going to be arrays? Is it going to be numbers? So in that case, I don't really know. So then what is going to be the return type? Well, if I don't know what's going to be getting passed inside of my array, well, then I don't know what I'm going to be returning. So I'm returning unknown, because I'm going to be returning a value that exists inside of my array. But since my array can contain different values, I don't necessarily know. Is this going to be a string? Is this going to be a boolean? Is this going to be undefined? Now I'll actually go ahead and start writing the functionality. So I need to return the value that is stored at the last index inside of my array. So in order to access the last index, I need to access the length of the array. And I need to subtract 1 from it. That will get me whatever my last index is. This is going to be a number because I'm just subtracting 1 from the length. Well, now that I have my last index, I need to return the element that exists at that last index. So for instance, right here, I should be returning the string accessories. Right here, I should be returning the boolean true. So in order for me to access elements inside of an array, I need to put the array of which I'm trying to access, and then inside of my brackets, the value or the index at which I'm wanting to access, which in this case would be last index. So now I've successfully found the element that existed at that index inside of the array. That's what it's asking me to return. So now I just need to return this. This is just mad at me because we already have a function called the same, but everything else functionally would be correct. And you can see we kind of did the same thing here. For here, I wrote it, I specifically put string array just because that's the only way that I called it. But in theory, it probably should have been unknown because it could have worked with both. But, any questions about how I kind of broke that down, Trey? And I'm not sure if that was helpful or provided any assistance.
No, that was great. Thank you very much. I just I actually created another variable called last index. And I had the correct answer in the console log, but I was getting a bunch of errors in the code. So, but that I mean, I perfectly understand what I did there. So thank you very much. Very helpful.
Sometimes you're going to get errors, and those are just going to be TypeScript errors, but they're not logically or functionally wrong. Like JavaScript may still execute this. So like, for instance, right here, if I miss a return type, you can see I'm getting errors, and you can see that ESLint is telling me missing return type on a function. However, if I were to run this in JavaScript, totally fine. I'm not going to get any errors back. So something to keep an eye out for errors is just because you're getting an error doesn't mean that you're doing something wrong. It just may mean that there's some weird typing or just something that needs to be fixed. but functionally, you may be on the right track. Rukaya.
So we've got this similar function in the functions practice exercise where we're supposed to find the first element instead of the last. Now here, what you did was you put in type unknown, right? What I did was the same thing. I did unknown first, but I forgot those brackets, which was why I was getting an error. But then when I changed it to any, there was no error.
Yeah. So any is like literally me telling TypeScript, like, I know better than you. Like, this can be any data type. So when I tell TypeScript, so like right here, I said that this is going to be any. TypeScript does not care how I use this element now. So now if I were to, or like, let me, rather than do that, so like string, let me change this to any. Well, now TypeScript doesn't care if I return a number, or if I return a string, or if I return a Boolean. So that's why we don't really want to use any, because it literally kind of gets rid of the main purpose of what TypeScript is there for, is to help us keep track of what data types we're working with. So people generally use any in the case of what you're running into, whereas like they're getting an error and they just wanted to get past the error, so then they'll put any on it. But the reason why you're not getting any errors is because when you tell TypeScript that something can be any, it's not going to check the data type of something, and it's just going to let it be whatever you tell it to be.
So even if I assign array as like the type of array would be any, it wouldn't check if it's an array or not.
Exactly. So now if I said array is any, it's not even going to literally check if it's in an array. So now let's say that I did array dot to uppercase. Arrays don't have it to uppercase. That's a string method. That's how it can convert strings. But since I told TypeScript that array is going to be any, TypeScript doesn't know that this is invalid. As soon as I say that this is a string array or something, for instance, well, now you can see I get an error, and it says, well, property does not exist in string array.
Okay. Okay. Thank
Yeah.
you.
Yeah.
So what with any, we can use any kind of functions.
You don't want to use any. I'm saying that you don't want to use any because it literally defeats the purpose of using TypeScript. But it's there in case you needed to use it. But that's why unknown is a little bit of a better choice, because unknown still has a little bit of type checking. It won't necessarily let me just like do anything with unknown, but it makes it more flexible to work with different data types. Awesome. So that was the get last element. So let's check out this one, do some code reading for this one. So Caroline, could you read 55 to 57, please?
Okay, on line 55, the function call other function is being declared with two parameters. Another function, which is a type of function, and a params parameter, which is unknown. And this will be returning an any type. On line 56, the other function with one argument is being returned. And on line 57, closing curly brace.
Awesome, thank you. Right, put these down, go. And then I'll finish this one off. On line 59, the call other function is being called with two arguments, the convert minutes to seconds, and 10. And that is being assigned to the variable call other function result of type number. And then on line 63, the log method of the console object is being called with two arguments, a string and call other function result. Take a look at the quiz questions on this one. So Noah, can you tell me what is a function in TypeScript?
That is the reusable block of code.
Yeah, essentially, it's just a reusable block of code. It's a block of code that I can now call anywhere throughout my whole application, and I can essentially just reuse that functionality. So it's a collection of lines of code that I can call upon whenever I want and to run those lines of code. Trey, could you describe the parts of a function definition?
I'm sorry, you're gonna have to help me with this one.
Yeah, no worries. So let's just take a look at a normal function. what are just kind of all the things that make up this normal function? What's the first immediate thing that we see that initializes that this is going to be a function?
Here, the
We have the function keyword.
oh yeah, okay, yeah. I'm sorry. You're talking about the syntax. I apologize.
Yeah. So I'm just talking about all the syntax that makes up a function. So we have the function keyword, and then we have the
Function name,
function name, and then what would go inside the parentheses?
the parameters.
The parameters, and then we have our, what do the curly braces mean?
Commit.
It's just a code block, essentially.
Okay, yeah, the code block. Sorry.
No worries. And then this keyword right here,
The return.
the return statement. Yep. So all the parts that make up a function definition is we have a function keyword. We have an optional function name. Any parameters are actual curly brace for the function code block, and then an optional return statement. Those are going to be all the individual parts that make up our function definition. Whereas in Rukaya, what about a function call? What are all the parts that make up a function call?
So we use the function name,
Mhm.
followed by the brackets, the parentheses, with arguments in it. So depending on the number of parameters we passed in, we pass in those many arguments.
Exactly. Yeah. So like on line 6, I'm calling a function. I'm calling my convert minutes to seconds function. So we have the name of the function. What function do I want to call? Then we have parentheses indicating that I'm calling something. And then any data that I want to pass into the function as an argument would go inside those parentheses. Yeah.
Oh, sorry, I just had a question about line 6. So here the function is being called convert minutes to seconds, and that result is being assigned to the variable.
Mhm.
And then we can use that variable throughout our code in the future.
I could log it.
For
Yep.
example.
I could have also just done
This one.
just called the function directly inside the console log and logged it. I just wanted to see what actually got returned from the function, which is why I was logging. Yeah.
Okay.
Caroline, when comparing them side by side, what are the differences between a function call and a function definition?
So the function definition is the code block that's actually defining the function. And the call is actually executing the function to run.
And syntactically, what are some differences? Like what exists in my function definition that don't exist in my function call?
So in the function call, we have the arguments. Those exist as parameters in the definition. And then we usually have, we have to match the call with the parameters value. And then I don't know what it is.
Yeah, and then we're missing like the function keyword,
Oh.
we're missing the, stuff like that. So, but yeah, exactly. So the function definition is where we define the function. The function call is where we actually call the functions. The main things that are, I guess, different is that we don't have the function keyword. So whenever I see the function keyword, that means I'm defining a function. Right here, I'm just calling a function. So we don't have the function keyword. We still both have parentheses. But when we call a function, that's where I'm actually passing in the argument. So the data, whereas in my function definition, this is my parameter, which is like a placeholder for the data that gets passed in when I call the function. So minutes is acting as a placeholder for 5 when I eventually pass in 5. And that's pretty much it. And brackets. Our function definition has our brackets for our code block, where when I call a function, I don't have those brackets. Yeah.
And when we call the function, what is the purpose of calling the function? Like
so that I can run this lines of code whenever I want.
Whenever?
Yeah, so like right here, convert minutes to seconds.
Like we can use the call of a function in another function to make something happen?
You can do that, yeah. And so like right here, like convert minutes to seconds. So imagine I wanted to be able to convert minutes to seconds. Well, if I ever wanted to convert minutes to seconds, let's say I didn't have a function. I would have to redo this line of code over and over and over and over and over. So let's say I had 10 different minutes that I wanted to convert to seconds. Well, so const hour 1 equals 5 times 60. Const hour 2 equals 10 times 60. You see, I just have to keep repeating myself. I have to keep repeating the same lines of code. But by extracting it to a function, I can now just call that function whenever I want, and it'll already perform this operation for me. So it's making my code reusable so that I don't have to keep repeating myself over and over.
I see. And then the input for those arguments when the function is to be called, how do those get inside that call?
Right here, because I'm passing it in.
Right.
So I'm calling a function and I'm putting 5. So when the JavaScript engine runs our code, it's going to call this function for me, and it's already going to pass 5, and it's already going to be replaced as minutes.
I see. But for example, if we had a like a form, and then we had a function that had to process that information from the form, then the arguments would be whatever the user inputted into the form.
No, the arguments wouldn't be that, because then that would be events, and then we'd be listening for a submit event, and then we'd have to get the form data from the HTML elements themselves. This is why there's functions that return something and there's functions that do something. I'm not always going to pass data into a function. I may, inside of that function, have to get the data from elsewhere, but sometimes there are functions where I do want to pass data into.
Oh, I see.
Yeah.
Well, thank you.
I can see like almost like a side thing. It looks like it's going back to the native language, like to other ugly languages like C and C++ by adding.
With what?
The TypeScript is going back.
Oh, yeah, it's
to like ugly languages.
yeah, ugly, yeah.
Passing-
That's statically typed language, yeah.
Passing the size with the array, I can see a return type.
But you see how beneficial it is to help us with the errors and the catch. Yeah, for sure. I think Noah, what is the difference between a parameter and an argument?
So the parameter is the elements of the function definition, and the arguments are the elements of the function call.
Yeah, exactly. So the parameter is a part of the function definition, so it's a placeholder. And then our argument is used alongside the function call, and it is the actual data. So minutes is acting as my placeholder for whenever I actually do call the function and I pass in an argument, that argument will then take the place of my parameter, which is how I can then access that data and stuff. Trey, why are function parameters useful?
Because they allow a function to receive the specific input values when they're called, I think.
Yeah, exactly. It just allows functions to receive data. So if I ever needed to pass data into a function and I wanted it to be able to work with it and do something with it, that's why parameters are useful. It gives me a way of being able to actually pass that data into a function. Rukaya, yeah, did you have a question now?
Yeah, it's regarding the parameters. And the function definition, are we getting the copy of the variable or are we getting the actual variable?
I looked into that a while back. I forgot.
Like C++.
I think, let's look it up. I don't know off the top of my head. In our parameters, copies of values or the values themselves, JavaScript. Parameters are copies of the values.
So it's not the actual.
So it doesn't affect the original variable. So if I pass the variable as an argument, and then if I were to change it inside the function, they're different.
But the way it does.
Because they're reference data types.
The reference
Exactly.
data.
Yeah, exactly. Rukaya, what two effects does a return statement have on a behavior of a function?
So if we use a return statement in our code block, it returns the value after the operation has been performed. And the second thing that it does is that it stops the function from running any further. So it like it'll just end the function right there.
Exactly, yeah. So we have two effects. The return statement can be used to actually return a value. So if I ever actually want to get something back from a function. And we could also use it to stop any execution of code. So we'll see the power of that once we get more into conditional statements and loops. But sometimes you've already met or found the one thing that you want to do. So you don't need any other code in your function to run. And sometimes you just want to kind of exit out and get out of the function. And we can use a return statement to our advantage to do that, to essentially just kick us out of the function. Caroline, what is the syntax for defining an arrow function?
It is the function name. Then there's parentheses that contain the parameters. Then there's the actual arrow. And then if we want to have an implicit return, we just continue without curly braces. And then if we want to write more code blocks, then we need to get the curly braces.
Exactly, yeah, exactly. So we'll have parentheses. Inside of those parentheses will be our parameters. Then we'll have the actual arrow itself, which is an equal sign and a greater than symbol together. And then, just as Caroline noted, depending on if we wanted to do an implicit return or an explicit return, we can either have no code block, no curly braces, or include a curly brace or block, and then a return statement, which we'll talk a little bit more out afterwards about the difference between the two. And then you can also assign it to a variable if you wanted to as well. Noah?
Yeah, the question here, why the get area? So we don't assign a data type to get area.
So in
Not
this
set
case,
to-
yeah, we could,
But it's a
Rukai was asking me about this. It's very ugly, whenever you have to type, functions. So right here, I assigned it an arrow function, but if I wanted to type get area, I would have to do.
Oh, no.
Yeah, exactly. But I'll show you because you asked, you know, so I'll,
What?
so it's almost like I have to rewrite almost everything again. So that's why
Oh.
I didn't include type annotations for the individual variables
Oh.
themselves, and then I just used it for the functions.
So pretty much the type of the get area is the width and height together.
No, so the type of. In this case, what we're actually doing is we're relying a little bit on type inference. And so you can see when I hover over get area, you can see it already knows what its type is. It knows that it's gonna be a function that'll have two
Oh, yeah.
parameters and it'll return a number. But on the functions practice exercise, I think there's specifically like a lint rule that will get mad at you if you don't explicitly include a type annotation if you were to use like an arrow function on a variable, which is why you would essentially have to repeat it as well and say specifically what is get area's type. Get area's type is a function that has those parameters.
Yeah, can we put instead of this the keyword function? Because it's a function.
Huh?
Can we put
We could, yeah, I mean, arrow function is just another type of function. So anything I could do with a normal function, I could essentially also do with an arrow function. So yeah, and I'll talk a little bit more about why I would want to use an arrow function versus a normal function in a little bit. Awesome. And then Noah, do you happen to know if an arrow function's body is not surrounded in curly braces, meaning we're using concise body syntax, what changes in its functionality?
Yeah, it's in the documentation, it says we only have one line return. It has to be one line.
Yeah, so we have something called an implicit return.
Yeah.
So you can see right here, right? I have an arrow function, but it has a curly brace for the code block for the function. So we have two different main types of body syntax. We have concise body syntax and we have normal body syntax. When we're using our normal body syntax with an arrow function, I explicitly need to include a return keyword. I need to explicitly return something. However, if I use concise body syntax, like down here, I don't need to include a return statement. So something like here where we did get first name alt, I said it's going to be receiving a person of type person, it'll return a type of string, and then I literally just put first name dot person. So when you use concise body syntax, meaning you do not have curly braces that are surrounding the function code block, then it has an implicit return, meaning this is automatically going to get returned to whatever I call the function. Whereas then if you can see now, if I included a set of curly braces, now you can see when I hover over a string, a function whose declared type is neither undefined, void, I'll remove the cameras because it was in the way, nor any, must return a value. So what is this error telling me?
That it doesn't have a return.
It doesn't have a return. So it's saying, hey, you told me you were going to return a string. What am I currently returning? Nothing. So what is the return type? Undefined or void. So since I do not have a return keyword, nothing is being returned. So that string is not being returned. So as soon as I add that return keyword, well, now you can see something is being returned and it fixed the error. If I have concise body syntax, I don't need to include the return keyword. It will already implicitly return whatever is right after that arrow function. Yeah, Carol.
And the arrow function still needs to be called, correct?
Yes, so in this, like, I would still have
You
to
would still
do
have to
get
call.
first name alt, and pass in the
And-
person.
And it's just better to use arrow functions as callback functions because they're shorter and they're just shorter to write.
Yeah, so that, I'll talk
Or
about it.
later.
No, I'll talk about it right now.
Oh.
So we'll kind of segue into that. So let's think about. So let's take a look at lines 71, 73, and 75. Immediately, what is the first thing that we read when we see lines 71, 73, or 75? What's the first thing that our eyes
The
go
name
to?
of the function.
Name, okay? What does the const keyword mean?
That it will not change.
It will not change, right? But what do I use const for? What do I create with const?
Variables.
Variables, right? So if I were to only look at just what I have highlighted right here, the const get area result, what does it look like I'm doing?
I think you're declaring a variable.
It looks like I'm declaring a variable, right? I am declaring a variable, but that variable is a function, right? So in order for me to be able to actually see that I'm creating a function, my eyes need to go from all the way over there to like all the way over here. Maybe I could have gotten it or seen it when I saw the parameters right here, but until I actually saw the arrow, I don't really know that it's a function. I may still think that I'm creating a variable. Whereas then let's look at line 1. What's the first thing that you see on line 1?
The function.
The function
Name.
keyword. So immediately right away, what do you think you know what we're doing? We're defining and creating a function, right? So the number one reason why we tend to use function declarations with the function keyword rather than arrow functions is for readability purposes. So a large portion of our code, our code is obviously writing what technically and functionally needs to happen to be able to perform whatever it is that we want. But we're also working with a team of other people. I want my code to be understandable. I want to be able to work with it. I want other people to be able to work with it. If let's say I were to walk away for like a couple months, and if I came back to my code, I want to be able to understand it clearly. So this is why generally, when it comes to normal standalone functions, it's better to use the function keyword. Because I immediately, for just the readability wise, immediately right off the bat know that it's a function. My eyes need to do less work to actually figure out what it is. Developers are lazy. I love to write code. I love to, get things done, but I want to be as efficient as possible and as little time as possible. So even if I could save myself 2 seconds on reading, that 2 seconds could add up and it makes things a little bit easier. So where arrow functions actually shine is something called callback functions. We're going to talk a lot more about callback functions in week 3, but I'll show you an example. So let's say I wanted to add an event listener to a button, and I wanted to listen for something called a click event. So a callback function is passing a function into another function as an argument. So in our case right here, add event listener is a function. I want to pass another function into this function as an argument. So I have 2 options of how I could do this. I could do a function, console log. Oh. Button was clicked. So I can do this. So I created a function right here.
In,
And I passed it as an argument to the add event listener. A method, but what is also a function. So where arrow functions really shine is for these kinds of functions, where I'm passing one in as an argument. I'll get to you in a second, Rakaya. So now if I rewrite this as an arrow function. And I could even do the console log directly like this. This is where arrow functions really shine, is when I'm passing a function into another function as an argument. Because usually when we create arrow functions, we usually create anonymous arrow functions, meaning I don't necessarily give it a name. And so in this case, I'm creating a function, but I'm only ever going to use this function in the context of this event listener. So it only exists right here. So that's where arrow functions really shine, is I'm creating it right alongside here. It's only ever going to be used here. I still could technically create it on its own, and pass it in. But this is where the majority of us are going to use arrow functions. Now, as you'll come to realize throughout your career, a lot of programming is very opinionated. Everyone writes code in different ways. So some people like to use, arrow functions for just every standalone function. Some people like that. I don't necessarily like that coding style. Robert doesn't necessarily like that coding style. This is how we prefer. We prefer to use only arrow functions as callback functions, and we like to use normal functions for every other function. There's another specific functionality reason, which I'll talk about in a second with hoisting. But this is mainly the key thing here. Rukaya?
So I just want to know, add event listener is like a built-in function, because here what we're actually doing is we're just calling the function, right?
Yeah, so add event listener would be a built-in function that existed on DOM objects, which we'll learn about in week 3.
Okay,
It's
thank
kind
you.
of like how when we work with arrays, push is kind of like a built-in function that exists on arrays. It's the same thing. There's going to be some like built-in or global methods or functions that we always kind of have available to us.
Okay, thank you.
Yeah, Noah?
So just regarding this, the event listener, so we are passing the anonymous, the line 72, we are passing anonymous function with its argument, which is click, right?
So in this case, add event listener is a function. It is being called with 2 arguments. The first argument to the add event listener function is the string click. The second argument to the add event listener function is the whole callback function.
Yeah, but my question is the string click, is it because it's a string of it is an argument of the anonymous function? No, anonymous.
It has nothing to do with this. It
Yeah.
has nothing to do with this function. Click has everything to do with this.
Because it's because it's getting argument passed from somewhere.
I'm the one passing the argument. I'm calling add event listener. What event do I want to listen for? I want to listen for a click event.
Okay.
Yeah. We'll learn a lot more about this on week 3, so I don't really want to get too deep in the nitty-gritty, but yeah.
yes, sorry. I was wondering, Sean, about the parameters before the function, the regular function. So the parameters are actually like, they're placeholders, but functionally, how can we use that parameter for our own benefit? Like a while back, Trey asked a question about this, and you said that the parameters can hold, like, for example, the input, or they can. What all does the parameter?
Whatever you want it to be, whatever you want it to do. It just depends on the function. Like in this case, I have a function called convert minutes to seconds.
And where would the minutes be coming from?
Where I call the function. Right here.
Okay.
So I call the function on line 6. I pass in 5. Now, when I run that function, because I'm calling it, minutes is going to have a value of 5.
Okay.
Yeah.
So for example, on a web page, if we had a little search, if we had a place where we can input minutes and click convert minutes to seconds, like it will be like a click, like convert, then automatically the function would take that value from that, pass it into the parameter, and then run the function and return the result for the user.
Yep.
Okay.
Mhm.
Thank you.
Yeah, of course. There's not every
Not
single
always.
function is gonna be from the user, like we're gonna write a whole lot of functions. So like with our APIs, like when I made an API call. The user doesn't necessarily always engage with those. Sometimes I'm doing that in the background. But it's the same thing, as I call a function, whatever I pass into the function call as an argument. Will then take the place of my parameters so that I can now use it inside of this function.
Oh, so that's why it's good to also create the functions to be reusable as
Exactly.
much as possible.
Exactly.
So not to think about, oh, I'm creating this function to make this specifically work, but create.
I mean, there are cases, like there
Well,
are gonna have functions that like they serve one
Yes.
purpose, where they only wanna do that one thing. But ideally, if I could, like this function makes it work so that it can work with any number. I can give it any number as minutes and it will always convert it to seconds.
Right.
Whereas then if I wrote this in a different way, maybe it only worked with 5. Well, now like the function's kind of useless because it only works with that one number,
Mhm.
So there's a concept in programming called DRY, which stands for don't repeat yourself. So you want to try to avoid repeating yourself as much as possible. So by having our functions be as reusable as possible, it's kind of like what I was showing right here with the convert minutes to seconds. If I wanted to convert minutes to seconds every single time, I would have to repeat that line of code over and over and over and over again. Whereas in now, since I extract it to a function, I just have to call the function and it'll do all the work for me. I just get the result back.
Okay, so rather it's good to think about creating simple functions.
Yeah,
that
ideally.
make simple logic.
Exactly. Yeah,
Okay.
yeah, exactly.
Not to make it like.
Yeah.
Okay.
Yeah, and you can try to like break things up into functions like as much as possible,
Yes.
so that way it's like smaller bite-sized
Uh-huh.
chunks, yeah.
Oh, okay, thank you.
Mhm. Awesome, there are a couple more things I wanted to talk about. Any other initial questions anyone have? Okay, so we already talked about normal functions versus arrow functions, kind of the difference between them, why I would want to use one versus the other. There's one thing that happens with normal functions, which doesn't happen with arrow functions. And that's something called hoisting. So, file these. Okay, so let me get rid of all of our changes here. Okay, and then let me comment all this out so we have less console logs to see. Okay,
How did you do that? Like comment the whole thing, there's like a.
so whenever as long as you just have multiple things highlighted, I'm not sure about Windows, but on Mac, it's Command/. So I assume on Windows it's probably like Control/ or something, but yeah. Awesome, okay, so on line 1 right now, I have my function convert minutes to seconds. Well, let's say that on line 1, now I tried to call convert minutes to seconds and pass in a number. Okay, on line 4 is where the function actually got defined. On line 1 is where I'm actually using the function. So I am using the function before I actually defined the function. Well, let's open this up and let's see what happens. You said it's not gonna work? Anybody else have any guesses? How many people do think it'll work? One hand. How many people don't think it'll work?
Trey.
Okay, Trey gave it a thumbs up. No, we got a thumbs up. Okay. Da 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 da.
Oh, what?
That worked. I got 600. I used the function on line 1, but the function wasn't defined until line 4. Why does that work? So JavaScript has something called hoisting. So essentially what's happening?
It's what?
Hoisting?
Hoisting?
Yeah, so hoisting like this. Essentially what that refers to as is anything that has this function keyword automatically gets moved to the top of the file for us. So we don't see it, but JavaScript, once JavaScript's engine goes through and parses our code, it essentially takes that line of code, shoves it up at the top. So even though in my code, the function was actually on line 4, when the JavaScript engine actually goes through and parses through our whole code to actually run it on the web browser, under the hood for us, it's actually taking every single thing with that function keyword, and then it's moving it up to the top for us. This is different than with arrow functions. And the reason why it's different with arrow functions is because I assign it to a variable, and variables do not get hoisted. So now on line 20, I have this get area arrow function. And if I were to now try to call get area, then I think I need a width and a height, right? So let's do 10 and 10. See, I'm already getting an error, so we already probably know something's wrong. And it says get area was used before it was defined. And now you can see that I get a reference error, cannot access get area before initialization. And that's because arrow functions, not necessarily arrow functions, but because variables, since I assigned the function to a variable, the variables don't get hoisted. Function declarations with our function keyword do get hoisted. So not necessarily something you run into on a day-to-day basis, but it is kind of a important thing to note that as long as you use the function keyword, it technically does not matter if you use the function before or after, because at the end of the day, they'll all get kind of hoisted. Which also, let's just say I had another function, log this. This. You can see I define the function on like line 9. I'm technically using it inside of here. So it doesn't really matter the order of them. Everything will get hoisted once the engine runs anyway. It'll kind of move everything to the top, and then JavaScript kind of just goes through it and kind of figures out the rest.
Is hoisting kind of like a hierarchy for the function versus variable, or
I wouldn't say
really?
hierarchy. I don't even really know why it exists, honestly. I
Oh.
think it's mainly just to make sure that like if you use the function, that function always existed, which is why they moved it. Technically, if we really want to get into the nitty-gritty, I said how there's 3 ways to create variables, right? We have const, we have let, and we have var. So let's create 3 different variables. So const, full name, const. Let's do the same thing as a let. And then the same thing as a var.
I feel like people using var.
So now I have 3 different variables. Okay, now let's try to log them up here. So full name variable. So full name const. Okay, so let's go one by one. So now I created a const variable on 8. I tried to log it on 1. I get an error. Cannot access full name const before initialization. Makes sense. Let's try to do it with the let. Same error. Cannot access full name let before initialization. Watch what happens with var. Undefined. I didn't get an error, but it doesn't have the value. It has undefined.
That's, yeah, it's dangerous.
So var technically also gets hoisted. So what happened is it essentially took the definition and then moved it to the top. Well, before the console log technically, so it'd be before right here. So the variable was created. The variable does not get its value until down here on line 12, which is why when I logged it, it has a value of undefined. It's been created, it's just undefined at that moment, and it doesn't get its value until down here. So technically, when it comes to hoisting, functions get hoisted, and also variables created with a var also get hoisted, but only the declaration, not the initialization. So only when you actually created it. So we don't use var, so not something necessarily need to be worried about too much. But yeah, no,
Is var is like is it the same functionality as const?
it doesn't matter. Var is like const and let. So which is why constant let got added, because var, it doesn't care if I reuse the variable, reassign it, it'll do whatever I tell it to do. Which is like a lot of people hated that about JavaScript because it was like there's no convention. So that's why we will force you to use constant let, because
Yeah.
it's the quote unquote better way of writing JavaScript now. Because we get the added benefit of making sure this is always constant, or this can change, and it helps us actually use them properly. Any questions about hoisting? Trey?
All right, so when the function is hoisted, it's not actually just the function name, it's actually taking the entire code block because it's returning the correct answer. Is that correct?
Yeah. So it's literally like what we just saw with var, we saw it literally only moved like where the variable got created, not where it had its value, but only where it got created. With functions though, it's like literally moving the whole code block up to the top, so that if I use it, it's still able to call it and do all the actual operations or whatnot. Okay, I got one more other thing that I'll talk about. Any other questions about that? Or I guess I got two more things I want to talk about.
I was just wondering, Sean,
Uh-huh.
can you turn down the air conditioning?
Turn it down as in like you're cold or you're hot?
I'm cold.
Oh, you're cold? Yeah.
Yes.
Yeah.
I'm
Okay.
in cold.
Yeah,
Yes,
I'll be right
thank
back.
you. Okay.
Cool. Cool.
Are they too warm in there? Thankfully.
Yeah, it's a struggle because in that, like, I don't know why they set it up that way, but in that room, our AC is there. But then in there, it's such a small room that they get really hot, but then out here, it's so spread so that it's like, so it's hard to find that balance.
Thank you.
Yeah, of course. Any other questions before I talk about the other couple things? Okay, so next thing I want to talk about is scope. So the concept of scope. So where we define our variables indicate where I can use those variables. So we have a few different types of scope. We have a global scope, we have function scope, and then we also have block scope. So let's say that I defined, let me comment all this out again, so that way we also just see less in that console. So, scope, yeah. So let's say that I created a variable, full name. Okay, so let's say I created the variable outside of any functions. It's in the global scope. It's not inside of anything, it's just inside of my JavaScript file. Well, now that this is in the global scope, I can use this variable anywhere in my code. So now, if I were to add a console log for full name inside of here. So I defined a full name variable in line 1 in the global scope. So it's not inside of any functions, it's not inside of any blocks or anything. It's just in the global scope. I am now trying to log that variable inside of my function. And when we run it, make sure I'm still compiling. It is. Where is my? Why is my JavaScript not getting updated? There we go. You can see it works. Okay, I'm able to actually access it. Now, let's say that I tried to do the opposite. Let's say that I defined my variable inside my function. And let's say that I tried to log it outside. Okay, so on line 3, inside of my function, I defined my full name variable. Well, now on line 10, I'm trying to log my full name variable. You can see I'm already getting a little red squiggly line, so you probably already know that something's going to be wrong, right? You see it says cannot find name, full name. Now when we run our code, you can see I get an uncaught reference error. Full name is not defined. So the scope, I like to think about it like tinted windows on a car. If you're outside a car with tinted windows, you cannot look in. Meaning, if you are outside of a function, you cannot look into the function. I cannot see or access any of the data inside of the function. However, if you're in a car with tinted windows, you can see outside. If I'm inside the function, I can see outside. So if there's anything in my global scope, I can access it inside of my function. But if there's anything inside of my function, I cannot access it outside of that function. Does that make sense? So it's not.
Yeah, I know.
Yep.
No.
Okay, so we have global scope, we have function scope, and we also have block scope. So we haven't talked about conditionals too much. Let's say we had a conditional.
Running forever.
That's fine. And this one's going to give it a string type. Okay, the last type of scope is block scope. So you can see on line 4, I created a full name variable. And now I'm trying to access it on line 6. I'm getting a red squiggly line underneath full name. See, I'm getting an error, cannot find full name. You can see if I hover over a full name right here, full name is declared, but its value is never read. I run it, full name is not defined. Because full name was created inside of these curly braces. So now this full name variable is only accessible inside of these brackets. This is block scope. So now this variable is only defined and workable inside of this block. So now if I were to console log it inside of here, you can see that it'll work there because now it's inside of that block. Now, let's say that I had a variable defined inside the function. But I wanted to access it inside of my if block. So I have the variable inside my function, but now I have another block with our conditional statement. I'm trying to log it. I'll give this a type. Count this out. We can see that it works. So this is where the order and kind of where you define your variables can matter. If something's in the global space, everything has access to it. I can work with it in the global space. I can work with it inside of functions. I can work with it inside of conditionals that are inside of functions. If something is defined inside of a function, not inside of any curly braces, so just inside of the curly braces for the function, they're just somewhere in the function, then it'll be accessible anywhere inside of the function after it was created. And then we have block scope, where if I create another code block, anything else that has another set of curly braces, then any variables created inside of that block would only be accessible within that block of code. So global scope, function scope, and block scope. Those are going to be the 3 types of scopes that we have, and depending on which one you use dictates where we can use those variables. Any questions about that? Yeah,
Did
Ellen?
you say it's good to keep important variables in the global scope? And then just use the ones we want to kind of work with? Like, for example, in the conditional statement, that we use it in like the function, just to be sure, like.
Yeah.
Kind of separate, organize.
Yeah, ideally, you want as many of your variables usually inside of your functions. You want to minimize the amount of global variables, but for important data, then you want it to be a global variable. So like in week 3, once we get into like our query selector, we want our query selectors in the global space, usually, because I want to be able to reuse those. So it depends on the data. If I have data, like let's say const full name. All right, let me just move this. I don't have to retype this. So let's say I have this full name variable, right? Let's say I used full name inside of this function and also inside of this function, then it would be better to have it in the global space because it's used multiple times. But if my full name variable was only ever used inside of this function, it would be better to only have it inside of that function. So it just depends on the data. Is it going to be shared through multiple spots through your application? Then you probably want it in the global space. Is that variable only ever used with one function? Then it should probably only be created inside of that function.
Okay.
Does that make sense?
Yes.
Yeah.
Thank you.
Huh?
But it's
No?
not safe, right? If you put like a global is gonna be somewhat in fact the system and can change everything, right?
Not necessarily.
So it's like better to do like put in different files so we can use it. Yeah, I was like thinking.
It depends on like, are you working with JavaScript frameworks? Are you working in vanilla JavaScript? But no, I wouldn't say, well, yes, ideally you want as little global variables as possible, but I wouldn't necessarily say that like global variables are like bad. We shouldn't have any. There are times where something needs to be a global variable. It just kind of depends on it.
This is why they use function at the top, like when you call different files, when you put the files at the top, so you can use its component. You see, like in Python, how you include the file at the top. Yeah, it's the same thing, right? Like.
Well, that would be import and exports, which you'll learn a lot more on the senior side.
Okay.
Yeah. Any questions though about the what we were just talking about with scope, global? All right, then the last thing I'll just talk about is the return statements. So we noted that return statements have two types of functionality. They can be used to return a value, but they can also be used to stop any execution of code. So let's say that I added a console log right here, running. Let me comment these back in. Already, we can see something probably going to happen. On line 4, you can see my console log is grayed out. And now if I run my code, you can see I never get that console log. Let me move it inside the function just to see if it does run. I get 1, but I don't get the second. And it's because a return keyword kicks you out of the function. So as soon as the function sees this return keyword, it's going to run this line, it's going to run this line, it's going to run this line. Oh, this line includes a return statement. I've now completed this function. Let me go move on to whatever is going to be left to go ahead and to do. So just important thing to note that a return statement will stop any execution of code. So if you had any code that was coming out after a return statement, it will not execute. And we can also use this to our advantage. So we haven't necessarily talked about loops and conditionals yet. We'll dive much more into those today and tomorrow. But for instance, let's say I had a loop and I wanted an array of numbers and I wanted to find like 7 in that array. Well, once I find 7, I don't need to worry about checking all the other rest of the array, right? I already found like the one thing that I was looking for. So then I can use the return statement to kick out and to stop and say, I already found the thing that I wanted. I don't need you to keep running anymore. So just stop any other execution of code.
So, but if we have a function that doesn't need to return anything, then just by calling that function, we make it run, right?
Yeah,
We don't always,
it's just always going to run everything inside of the function.
it's just gonna run everything. Okay,
Yeah,
so I just want to clear.
Well,
Huh?
well, what about if we see like in some code return true, return false, return?
What do you mean? I'm not sure I'm following. I mean, sometimes I can still return a Boolean, you know, like I can still return true or return false or whatever. It's just whenever I use a return keyword, it's going to stop any other additional code. So regardless of what I return, you can return strings, you can return Booleans, you can return whatever. It's not going to run any code after the return statement.
So when it says return Boolean, when you return true or false, the return has to be Boolean. Like
Exactly. You can see right now I'm getting an error and it says type Boolean is not assignable to type number. Because what is my current return type?
So that's be expression, expression somehow, and then,
So then I would just change this to Boolean. Oh, if I could spell Boolean, and then now you can see that it's fine.
oh,
That's the great thing about TypeScript.
Yeah, exactly.
It-
It really helps you to make sure that like, hey, you told me you were gonna return this, you're not returning this, you know, you're making a mistake somewhere. It's like our little kind of pair coding assistant. Awesome, that was pretty much everything I wanted to talk about with functions. Were there any other questions that anyone had about functions? Yeah,
there's only the recursive functions,
huh?
the recursive function.
Yeah, what about them?
Are we gonna learn anything about it?
We don't, I think we were talking about this yesterday. Out of every single line of code I've written since I've become a developer, I've never had to use recursive. It depends on what you're doing. You know, it's like from our perspective, I don't need to use recursive that much. If you're doing like data science, or it's like you're having to run a lot of analytics and you're having to do a lot of like web scraping, a lot of data, then you'd have to do a lot of recursive functionality. But for us, we don't really have to do a lot of recursive.
So it's just like a function call itself.
It's just a function that keeps calling itself.
Yeah, with the syntax, I was like, it's
Yeah,
weird.
I mean, we could look up let's ask. Give me an example of a recursive function in JavaScript.
Can't look at this, it's ugly.
Yes, so factorial is like the most common one. So for instance, like right here. So I have a function called factorial. It is going to be receiving a number. If the number was 0 or 1, then I'll just return 1, because that means that I found the factorial. Otherwise, what I'll do is I'll call the function again, subtract 1, so that way my number goes down by 1, and then I multiply it by n, which is how you find the factorial. But that's all recursive is that you're just calling the function that you're in inside of your function, but you change the data that you're giving it, otherwise you're kind of always stuck in like the same spot. That's all recursive is that you just keep calling the function that you're in until you eventually find your desired result. So this is going to keep calling this until we eventually get our factorial.
So the first one is the first function is the end of the.
And so I guess this is like a little breakdown. So we call factorial. Oh, this is hard to see on the. Let me copy this and put this in our code over there. It's easier to see with the white.
But we're not gonna use it, right?
We're not going to use it. We're not going to use it. But just so that you can see syntactically what's happening. So I call factorial with 5. So now I'm doing 5 times factorial 4, because I'm subtracting 5 minus 1. So now, and it's just going to keep on going. So that's all it's doing is it's just keep calling its function, but I'm just passing in a different number every single time. Any other questions about functions? All right, awesome. Then let me stop our recording.